This is a Project 14 do-it-yourself instrumentation project based on a BBC microbit. And we can see the microbit over here, and what I've done is connect it up to an LCD over here. And we have the power switch to turn it on, and there's a battery inside here, of course. And you can see all the sensors that are in the microbit: the temperature sensor, voltage sensor or analog input, the compass or heading, X accelerometer, Y accelerometer, and Z accelerometer. So this is a sensor instrument based on BBC microbit. Now the normal display that's on the microbit could be used to scroll this information, but it's really not very effective in terms of getting fast readings and using this in a real application. Right now I can use it as a temperature sensor, a level for determining angles. I can use it as a compass to determine my heading relative to magnetic north. And of course the accelerometers can be used for acceleration as well as tilt sensing. So a very useful instrument, and I have here an input port for an analog voltage so that I can read voltage, which is showing here in the second line. And I'll run through each of these sensing technologies with a little demonstration. The other port over here is for charging the lithium polymer battery that's inside here. And it's quite a nice flat case, as you can see. I did leave access to the microbit USB connector, and it's rectangular so that it will sit on any surface and allow me to get the level readings from any surface. Here I'm going to take the microBOSS apart just so you can see how it's constructed inside. There's a back plate here which is not screwed together, just so I can take it apart for this demo. So there's a lid with a bezel for the microbit, all 3D printed, and then there's the screw mounting screw holes here. The microbit into a connector which is soldered to a custom printed circuit board, which makes the connections to this SPI LCD graphical display. And you can see on the other side I have a lithium polymer battery wrapped in Kapton tape to prevent it shorting from anything in there. And it just drops in to the faceplate. And you can see that the buttons come through nicely on the front of the bezel. Now that's what's inside. This little demonstration is just the accelerometers in the microBOSS. So here we can see that the X accelerometer is reading about 0. So X is in this direction, which is perpendicular to gravity, and we're getting almost no reading there. The Y direction, which is vertical, we're getting about 1024 to 1040 milli-Gs, which is about 1 G of acceleration. And the Z accelerometer, which is in this direction towards the face of the device, is also reading nearly 0 because it's also perpendicular to gravity. If I rotate this so that the X direction is now in the vertical direction, we can see that the X has gone to 1040 milli-Gs, and the Y direction, which is now in this direction, has gone to 0 because it's now perpendicular to gravity. And of course the Z is still perpendicular to gravity and reading 0. As we tilt it, you can see that the Z in this direction is changing because this is now tilting slightly towards gravity. If I tilt it this way, the X and Y are both changing, but Z is still perpendicular all the way through this rotation. And we can see here that the X direction is positive 1G, or 1040 milli-Gs. And if I rotate it all the way around, we'll notice that it has gone to minus 1024. So it has gone in the opposite direction now because gravity is pointing towards the other face of the device. And all axes are working that way. They go plus and minus. And the accelerometers can actually measure above 1G if you accelerate this thing, rather than just depending on gravity for acceleration. But it's pretty good at measuring acceleration in 3 different axes. This demo is about the temperature sensor. So I popped this device into the freezer for about 6 minutes. Let's see here, the temperature is reading 1 degree. So we'll have to warm it up a little bit. Let me put my hand. Temperature sensor is actually on the microbit just about here. But it's going to take a while for the heat to get through this package. The temperature in this room is about 20 degrees. Just went up to 2 degrees. Obviously I'm not very hot because I'm not warming that up much. There we go, 3 degrees. But the temperature sensor does work, and it's just buried in that package, so it takes a while for it to stabilize and to react to ambient temperature changes, which also don't change very fast, so it's perfectly fine for measuring ambient temperatures. It's up to 4 degrees, and I'm going to probably skip a little bit of time here and get it up higher. Well, the temperature's up to 7 degrees, just a couple of minutes. So programming this device was pretty tricky. I ran out of memory a few times because I wasn't all that efficient with my memory usage, particularly the RAM. But it's certainly working well now. It's displaying everything I want, and it's up to 8 degrees now. So up to 9 degrees, and we'll be back with the voltage measurement. Alright, I'm going to show how to connect voltage to this microBOSS. The first thing I'm going to do is show you the connector system. This is from the AMP division of TE Connectivity, and it's the MTA series. They have all different colors, which are color-coded to the different wire diameters or wire gauges that you can use with them. These are insulation displacement connectors, and they're about as fast as you can make connections. So the main drawback is that the tool is quite expensive. But you just slide the connector in, and then you plug in the wire. In this case, we're just going to plug in the ground wire, and then the power wire, and then the signal wire. And it's done. So no soldering, no muss, no fuss. And then we can just plug it in here. And we have ourselves a pot. So let's turn this on. And we'll look at the voltage, which is the second reading here. It's reading 2.5. If I rotate the pot, it goes up to 3.17. And then if I rotate the pot all the way down, it's going down 2.4, 1.3, 1.2, all the way to 0, 0.012. So that's a quick example of a microbit actually measuring voltage based on a pot. And I've brought out a power pin here so that I can run the pot. But you could put in any voltage below the power supply of the microbit into this connector. Or you could put a voltage divider and put in higher voltages. So this is the microbit of sense system, or microBOSS, and we're demonstrating its compass capabilities. So I have a clear turntable down here with a static compass bearing below it, and then I'm just going to rotate the camera and the microBOSS at the same time so that you can read the microBOSS. Let's turn it on, and it's scrolling its microBOSS message, and then it's displaying the readings over here, and you'll notice that the heading is the third one down, and it's reading about 0 here. So if I rotate this, it will show about 90 degrees or east over here. And continuing on, we should be facing south here, or 180 degrees. And I hope that we can read that. This is west, or 270 degrees. And coming back to north, or 0, or about 360 degrees. So fairly straightforward demonstration, but just to show that the compass works. This is, I haven't taken any pains to eliminate nearby metal